Hello guys and welcome back to MathZone. In this video, we are going to focus on transformation of functions where we modify the functions and also the graph. There are 6 transformations. Let's look at the first one. The first one, we have vertical translation. Vertical means that we move the graph up or down, translations, by b units. Or we can say by the vector 0, b. Means that we move it up or down by b unit, but we don't do horizontal translation at all. The algebra changes if we move the graph up or down. Let's say the original function is fx, means that if we move it up or down, we just add the function with plus b. So if you look at the graph illustration, this is the example, fx equals to x squared. If you move the graph up by 2 units like this, means that the fx, which is x squared, we add by 2. But if we move it down by half, or we say down with minus half, means that the function will be x squared minus half. So if you move it up, just plus that number, move it down, just minus. The second one, we have horizontal translation. Translation means we move the graph horizontal to the left or to the right by a units. We can say by the vector a0 means that we move the graph by a unit horizontally, but we didn't do the vertical translation. The algebra changes from the original function. If you move the graph to the left or to the right, you don't modify the fx plus something or minus something like we did in the vertical, but we modify the x. So we replace the x with x minus a. Let's look at the example. This is our fx equals to x squared, and let's say we move it to the right by 1 unit. What happened is, this is we move it to the right by 1 unit, but in the formula we have negative, so we replace x with x minus 1, so it becomes x minus 1 squared. But if we move it to the left, let's say by 2 unit, so left minus 2, something like this, the equation will be x minus from the formula, and then your a is minus 2, so x minus minus 2 squared, or x plus 2 squared. So a little bit different, guys. So the vertical, you move it up, you plus the function with 2, you move it down, you minus with half, for example. But in horizontal, when you subtract by a value, if you subtract your x with a value, means that we move it to the right. We do the opposite. And then if it is to the left by 2 unit, that means we plus by 2. Plus means to the left. So be careful with the algebra operation in horizontal. The third one, we have reflection in the x-axis. So we multiply all the y's that we have by minus 1. So the algebra changes from fx becomes negative fx. We multiply all the fx or all the y's with negative. It says fx equals to square root of x. So the y value, let's say this is 1, this is 1. And then we have 4. With square root, you will get 2 here. Now, when you reflect the graph in the x-axis, means that we multiply the y's by negative, but we keep the value of x same. So this is minus 1, this is minus 2. And then the graph will look like this. Wait, let me use black one. As you can see, you multiply all the y value with negative, but you keep the x value same. Or if you look geometrically, this is like reflection in the x-axis. So this is the fx equals to, or maybe I write down the new one, minus square root of x. We also have reflection in the y-axis, where we multiply all the x that we have with -1. The function will become f negative x, means that we replace the x with negative x. So this is our fx equals to square root of x. So we have 1 and 1, we have 4 and 2. So we multiply the negative, so 1 becomes -1, 4 becomes -4, and this is our graph. Pay attention that the y values not change. So from 1 becomes -1, 4 becomes -4, but you keep the y value same. Or geometrically, you can just draw the graph. This is like the image of the reflection of this function in the reflection of y-axis. So far we have 4, and you should look at the pattern. If it is vertical, we modify the fx. So fx become fx plus b. Reflection in the x-axis, it is vertical translation. So you multiply fx with negative. But horizontal translation, or reflection in the y-axis, or we can say horizontal reflection, we replace the x, not the fx. So this is x become x minus a, fx becomes f minus x. The fifth one, we have vertical stretches, where we stretch by a scale factor a parallel to the y-axis because it's vertical stretches. Or we can say we multiply all the y's by a. We keep the x-axis same, or we call it x-axis invariant. The algebra changes from fx becomes a times fx, means that we multiply all our y or fx by a. So this is the graph. Let's say I have fx equals to x squared. So I want to make a graph of, let's say, 2x squared. How do we do that? So let's say this is, I have 1, this is 1, I have 2, this is 4, I have 3, I have 9 here. Now, if I multiply by 2 all the y values, so from 1 to 2, but we keep the y, the x invariant from 4 to 8, maybe I'll use different colors so you won't be confused. So 1 becomes 2, but keep the x value same. 4 becomes 8. 9 becomes 18, which we cannot draw it. 0 still 0, so this is the graph. As you can see, we stretch it vertically from 1 to 2, 4 to 8. Yeah, the graph looks ugly, but it's okay, as long as you understand what it means by that. Horizontal stretch, where we stretch by a scale factor 1 over a parallel to the x-axis. That means we multiply all the x by 1 over a, and we keep the y-axis invariant. So the changes is fx becomes fax. But pay attention, before it follows, you multiply by a, the scale factor is a. But horizontal stretch, the scale factor is 1 over a, but we multiply by a, so it's kind of the opposite. So for example, this is fx equals to x squared, and I want to stretch it horizontally with stretch factor 2. So let's say I have 1, this is 1, I have 2, this is 4, I have 3 here. Yeah, maybe I just need 2 points. And then we stretched by factor 2, means that from 1 multiplied by 2 becomes 2 here, 2 multiplied by 2 becomes 4, but you keep the y value invariant. So the graph will becomes like this. We multiply all the x value by 2. But be careful with the algebra. So this is f(a)x, the stretch factor is 1 over a. Now my stretch factor is 2. That means it's opposite. That means my fx will become, we replace our x with ax, but a is opposite from the scale factor, so my a is 1 over 2, the opposite. So that becomes half x, and then you square it. So be careful with the stretch factor and also its algebra. Notes: horizontal transformation follow the opposite order to the normal order of operation as used in arithmetic. So let's say I have fx, and I want to move the function or translation, maybe I should write translation, to the left by 3. The transformation horizontal means that we move it to the left will follow the opposite order to the normal order as used in arithmetic. Means that if it is horizontal, we replace the x. But maybe we think, oh, to the left is negative. But no, horizontal always follow the opposite. So it becomes plus 3. Usually we think negative as to the left, but horizontal always follow the opposite. And that same for stretch. If you do horizontal stretch, let's say by scale factor, now it's 1 over 4. Maybe we think, oh, we just multiply all the x by 1 over 4, but it's not. You need to multiply by the opposite. 1 over 4, the opposite is 4. So it becomes f(4x). So that is the horizontal transformation. If you move to the right by 1, that means it becomes x minus 1, opposite. If the scale factor is 3, means that we multiply our x not by 3 but with 1 over 3. So it's always opposite if it is horizontal transformation, but vertical transformation follow the same order to the normal order as used in arithmetic. Okay guys, now we can combine two transformations together, but be careful. If we want to combine two vertical or two horizontal together, the order may affect the outcome. Let's say I want to combine two vertical transformation. The first transformation, I stretch vertically by factor a, means that we multiply my function by a. So from fx, we multiplied my function with a, it becomes a fx. And then we do the second transformation, but same vertical transformation, which is translate 0k, means that we add k to the function. This is vertical translation. That means we add all of this by k. So a fx plus k. What if I switch the order? I do translation first and then I do stretch after that. If you do that, we translate first means that we add the fx by k first, and after that, this is my new function and I stretch it vertically by factor a, we multiply my new function by a. This is my new function, so we multiply all by a, so that will give you a times my new function, or it becomes a fx plus a k. As you can see, these two are different outcomes. So when you combine two vertical transformations, the order matters. Be careful. This one, I have two horizontal transformation. Let's say I translate that with C unit by C unit. That means my function will become, I replace x with x minus c. So that becomes fx minus c. And my new function, I stretch horizontally by factor 1 over b. That means I replace my x from new function by with bx, because the scale factor is 1 over b, becomes bx. So that means I replace my x by bx. So it becomes f bx minus c. That will be different if we stretch horizontally by factor 1 over b first. So I replace my x with bx. So it becomes f bx. And then I translate that by c. Horizontally means that I replace my x with x minus c. And that becomes, I replace my x in the new function by x minus c. So that will give you f bx becomes x minus c. And that becomes f bx minus bc. As you can see, the order matters because that will give you different outcomes. But when you combine one horizontal and one vertical together, the order does not affect the outcome. So you can do any transformation first, up to you which one that you want to do it first. Okay, let's solve the first question. In each parts of ABC, we have the original function with solid lines and the broken lines for transformation one, the transform one. So the first question is, state in terms of f the equation of the graph shown with broken line. So the solid lines, this is my original function and we want to transform it into this. As you can see, it's very clear that this is the reflection in the y-axis. Geometrically, you can see this is reflection on in this line. Or you can see that you multiply all of your x value becomes negative. From 1 becomes negative 1, this is the point. From 2 to negative 2. And then from 3 up here becomes negative 3. So that means we multiply all the x by negative 1. So this is reflection in the y-axis. So that means the function is f minus x. Means that we multiply all the x with negative. The second one, we have this graph. As you can see, this is my original function and this is my transform one. Now, should look at the pattern here. Maybe we can look at this point. This point transform into this. As you can see, the x value does not change, but we change the y value from 1 to 2. And then we have this point, 2 becomes 4. So that means from 1 to 2, 2 to 4 means that we multiply by 2. So the purple one multiplied by 2. If you look at this, this is 3. This is 3 becomes 6. So we multiply the y value by 2. That means we do a stretch, vertical stretch. So should write here. So this is vertical stretch because we multiply all the y's with 2. That means vertical stretch by a scale factor 2. So that means our graph, we multiply all the y's with 2. So that means it becomes 2fx. In part C, this one is a little bit tricky because that changed the whole shape of our graph. So maybe it contains two transformations. So, as you can see, the shape, in terms of shape, it's not changed, right? It's like V, like this. But you move this two times. The first one you move to the left and then you move down. By how many unit? Let's focus on 1 point only. So this is 2, 1 and we want to translate it here. So from 2 to -2 means that we do horizontal translation by the vector. Horizontal means that we put here -4, 0, because from 2 to -2 we move it to the left by 4 unit, or we can say -4, 0. And after that we move it down. This is 1 becomes -2. That means we move it down by 3 unit. So we can say it's vertical translation. Vertical means that we put the number here at the bottom, the vertical, by 3 unit down, so it's negative. And then we put 0. So we combine this together into one translation vector scale. So it becomes -4 and -3. So that means the equation will be, first thing first, we move it left by 4 unit. The formula is fx minus a. So this is negative and meets negative, so it becomes plus. So it becomes fx plus 4. And after that, vertical translation, we add our fx by -3. So it becomes fx minus 3. So you add the new function here with -3. So this is the horizontal translation part. This is the vertical translation part. Hello guys, let's look at the second question. We have the diagram shows the graph of y equals to fx, which consists of the two straight lines AB and BC. The lines A dash, B dash, and B dash, C dash form the graph of y equals to gx, which is the result of applying a sequence of two transformations in either order to y equals to fx. State fully the two transformation that we have. Okay guys, let's look at this function. In this function we have ABC, this is the original one, and we transform it. We apply two transformation, it becomes A dash, B dash, and C dash. So if you look at the graph, it's very obvious that we have to move down our graph first. So it becomes, we move it down by 2 units, so A from here to here, B by 2 unit down, and C 2 unit down. So this is the first transformation, because if you look at the pattern, we move it down first by 2 unit. So the first transformation is vertical translation, or we can say by the vector 0, -2, because we move it down by 2 units, so we -2. And vertical means that we put the number below here. And after that, what happened with my new graph here? As you can see, if you look at the pattern, the width changed. Before it is 3 unit, the width. Now the width becomes 6. That means we do stretch. We multiply all of our x by 2 unit. So that means we do stretch. So let's say this is my point here. The x is 1 and it becomes 2. So we multiply by 2, my x value. My b from 2 to 4. We multiply by 2 as well. The c from 4 to 8. That means we multiply by 2 as well. That means we can say this is the stretch horizontal stretch. By scale factor 2. Because we multiply all of our x, the horizontal one, by a scale factor 2. Keep in mind that the transformation can be in either order. Because one is vertical, one is horizontal, so the order does not matter. Let's look at the next question. Here we have fx and gx. This is my fx, this is my gx. Describe fully a sequence of two transformations which transform the graph fx to gx. So my original one is fx. So if you look at the graph, this is our fx. Sorry, this is my fx, and we want to transform it into gx. The first step, as you can see, we have to move our fx first. So from here to here. And then it's one unit like this. Sorry, this one. And after that, up to this point. And then like this. Nah, as you can see, I move it. By how many units? Let's focus on one point. This is 5. This is -1. So from 5 to -1, we move it to the left by 6 units. So that means the first transformation is horizontal translation If it is horizontal, means that we write the number here on top, -6 because it's to the left, and then 0 means that no vertical translation. This is the first one. The second one, as you can see, my graph, you stretch it vertically. So that means we multiply my y value with a certain value. Let's say this is the point, this is 3, become 6. So we multiply by 2. And after that, this is my point here. This is -3. And then it becomes -6. Means that we multiply by 2. So that means we do vertical stretch by a scale factor 2. So these are two transformations. Because one is horizontal, one is vertical, that means, once again, the order does not matter. You can write down the stretch first and then the translation first. Let's look at the next question. Here we have the graph of equation y equals to fx is transformed to the graph with equation y equals to gx by a stretch in the x direction with a factor 0.5. So this is my first transformation. Stretch in the x direction with factor 0.5. And then followed by transformation of 0, 1. On the diagram, we have fx. The question is, we need to sketch the graph of y equals to gx. So, first thing first, we look at the first transformation, which is a stretch in the x direction with a scale factor 0.5. Means that we multiply all of our x value with 0.5. So, this is 0 multiplied by half becomes 0 still. This is 1. My x value is 1. We multiply by half, so it becomes this one, the point. Then we take straight line here. And this is 2 becomes 1 because we multiply by half. So it becomes this point. And then you continue to make the pattern. So this is my new function after we stretch it by half. This is 4 becomes 2. This is 3 becomes 1.5. And after that, we followed by translation of 0, 1. If you look at the number here, this is horizontal translation, which is 0. We don't do the horizontal. This is the vertical. That means we move the graph up by 1 unit, vertical. positive, so that we move it up by 1 unit. So my new function will be this. Should use this one. We just move it. Nah, maybe you should use pencil so you can erase the working, the red one. So I will not erase that. So I just want to write down this is the final answer. This is my gx. But later in the task, maybe you can use the pencil and you can erase the working here. The second one, find an expression for gx in terms of fx. As you can see, this one is horizontal. And after that, this is vertical. So the order will not affect our equation because one horizontal, one vertical. So we can do which one that you want to do it first, but let's do the order. So the first one is a stretch in the x direction with factor 0.5. So first thing first, we apply horizontal stretch by a scale factor 0.5 or half. My function from fx will becomes f2x. Pay attention, if it is horizontal, we do always do the opposite. Scale factor 1 over 2, that means we multiply my x or we replace my x with 2. 1 over 2 becomes 2. We do the opposite. And the second one, we have f2x. We translate that 0, 1 means that this is vertical. So we just add my new function, f2x, and then we add by 1. So this is my answer. Okay guys, so let's look at this question. This is all algebra. So we have two functions, fx and gx, and you want to change our fx into this form, which is the completed square form. So let's do it. This is our fx. Fx equals to x squared minus 4x plus 9. So we do completing the square. For this part, as you can see, the b is minus 4. We divide by 2, becomes minus 2. So we put the bracket, we put our x, we put this number, and then we square. And then we expand, becomes x squared minus 4x plus 4. This is plus 4, but we have plus 9. So that means from plus 4 to plus 9, we have to add by 5. So it becomes x minus 2 squared plus 5. And after that, we have gx. We want to change it into this form. 2 in the bracket, x plus c squared plus d. So what is my gx here? So my gx is 2x squared plus 4x plus 12. As you can see in this form, we take out 2 from all of this. So we can factorize the 2 from all the terms that we have. Becomes 2 in the brackets, x squared plus 2x plus 6. From here, we do the completing the square. So we focus on this first, x squared plus 2x. The b is 2. We divide by 2 becomes 1. So our equation becomes the bracket. We put my x. We put my 1 here. And then we square. And we expand to check x plus 1 squared equals to x squared plus 2x plus 1. This is plus 1, but my equation plus 6. So from 1 to 6, we have to add by 5. So this is my answer. The next question, we want to express gx in the form of k times fx plus h, where k and h are integer. So as you can see, this is a transformation. I want to transform my fx into gx. I want to transform my fx becomes kfx plus h. So what is my fx? My fx is x minus 2 square plus 5. And my gx, which is the transform one, is 2x plus 1 square plus 5. So let me write down first. 2x plus 1 square plus 5. Okay, now this is my original. I want to change it into this. 2 times x plus 1 square plus 5. It's very obvious. The first transformation is we multiply all of my function with 2. Because this is 2. You have to multiply by this big guy. So we can multiply this with 2 first. So it becomes 2 times x minus 2 square plus 5. This is the vertical stretch. And after that, we compare. This is minus 2, this is plus 1. That means from minus 2 becomes plus 1, we need to add by 3. So this is 2 times x minus 2 plus 3, the extra, because you want to make it becomes plus 1 square plus 5. Maybe the transform one I should use different color so you can see the difference. Okay, now as you can see, my k is 2, this is 2, times my red one is fx, right? The red one is fx. So 2 times fx, but my x we need to add by 3. So it becomes 2fx plus 3. So the answer is 2fx plus 3. In part D, we need to describe fully the two transformations that have been combined to transform the graph of y equals to fx to the graph of y equals to gx. So let me copy paste my answer here. Or maybe I don't need to copy. I just care about the last one, this and this. So from fx, we want to change it into 2fx plus 3. So, as you can see, we can have fx and then we multiply by 2 becomes 2fx, and then we replace x with fx plus 3. So become 2fx plus 3. The first transformation from fx becomes 2fx. We need to do the vertical stretch. So the first one is vertical stretch by a scale factor 2. Because we multiply my fx or my y with 2. And the second one is we replace x with x plus 3. So this is horizontal translation. And remember, horizontal always do the opposite. Plus 3 means that we move it to the left. So it's minus 3, 0. So this is the answer. Let's move on to the next question. Here we have the curve with equation y equals to x squared plus 2x minus 5 is translated by minus 1 and 3. Find the equation of the translated curve, giving your answer in the form y equals to ax squared plus bx plus c. So as you can see, we do two translation. This number represent horizontal translation. And this number represent vertical translation. So let's do the horizontal first. So we have y equals to x squared plus 2x minus 5. And we do horizontal translation. It will become fx minus a. Our a is minus 1, so it becomes fx plus 1. So that means we replace my x with x plus 1. So we replace all of my x with x plus 1. So it becomes y equals to x plus 1 square plus 2 times x plus 1 minus 5. And after that, we do vertical translation. That means my new function, the latest one, yeah, we do vertical translation means that we add by a, yeah, or maybe with b, because we already use a. So what is my b? This is my b, which is 3. So that means if it is fx plus 3. So that means we add all of this by 3. We just add once. So x squared plus 1 plus 2 times x plus 1 minus 5 and then plus 3 at the end. So here we have the transform 1. We just need to expand to simplify. So we have x squared plus 2x plus 1, the expansion of this, plus we expand to x plus 2, and then minus 2. We cancel 2 here, so we will have x squared, 2x becomes plus 4x, and then we have plus 1 here. So the answer is x squared plus 4x plus 1. The second one, the curve with equation y equals to x squared plus 2x minus 5 is transformed to a curve with equation 4x squared plus 4x minus 5. Describe fully the single transformation that has been applied. So there is a single transformation to transform this into this. So we should think, let's say this is fx, x squared plus 2x minus 5. We want to change it into 4x squared plus 4x minus 5. This is the trick. If you have this equation, as you can see, the constant doesn't change. Means that we don't do vertical transformation. But if you pay attention, this is x squared becomes 4x squared. This is 2x becomes 4x. That means we do horizontal transformation. As you can see, from 2x becomes 4x means that we replace x with 2x. And that also works for x squared becomes 4x squared. So we can rewrite our function here, 4x squared plus 4x minus 5. We can rewrite it as 2x squared plus 2 times 2x minus 5. Now the original one is x squared plus 2x minus 5. We replace x with 2x. That means we do horizontal stretch. The answer is horizontal stretch. Because the scale factor is, because the number here is 2, that means the scale factor will be opposite. Remember, when do horizontal, it's always opposite. So horizontal stretch by a scale factor 1 over 2. So this is the answer. Okay guys, let's look at the last question here. The graph of y equals to fx is transformed to the graph of y equals to 3 minus fx. Describe fully in the correct order the two transformations that have been combined. So, as you can see, we have two transformations, says here in the correct order. If you look at the transform 1, we have plus 3, and then we multiply our fx with minus 1. Both of them are vertical transformation. As you can see, this is the vertical transformation where we do reflection in the x-axis. This is vertical translation where we move the graph up by 3 units. So we have to do it in order. From fx, our goal is 3 minus fx. That means we need to minus first our fx. So the first one we do reflection in the x-axis. The second one, after you minus fx, you add by 3. It will becomes minus fx plus 3. So you will have vertical translation by the vector 0, 3. So this is our answer. We cannot do the vertical first and then reflection. Why? Because if you do the reverse, what happens if we swap the order? If we do vertical translation first, so this is my fx, and then we do vertical translation, it will become fx plus 3. Plus 3, and then we multiply by -1, the whole thing, you will get minus fx plus 3, which is minus fx minus 3. As you can see, it's different, so this is wrong. This is not the answer. So our answer is this one.